Okay, we're going to introduce exponential functions. And the reason these functions are called exponential functions is because the variable is in the exponent. Okay, so exponential functions are of the form f of x equals a to the x, where a is just a constant, it's a number, it's greater than 0, and it's not equal to 1. Okay, if it was just 1, it would just be a constant function. So here we're talking about numbers greater than 0, not equal to 1. So just to explore a little bit, let's graph a couple of these on our graphing calculator. So first we're going to graph f of x equals 2 to the x. So we can just use that little caret. Okay, there's 2 to the x. And so what's happening, we can look at the table. You know, if we put in 0, well, 2 to the 0 is 1. Anything to the 0 power is 1. 2 to the first power, if we put in 1, is 2. Then when we put in 2, we're saying, what's 2 squared? Well, it's 4. Okay, so you'll see that this gets big really, really fast. And we're plugging that variable into the exponent. Now, on the same graph here, let's see what happens when we put 3 to the x. And let's make this one bold just so we can tell the difference. Okay, so there was our original 2 to the x. And then there's our 3 to the x. And, you know, if we want to kind of put them in different colors over here, so we'll do this one in blue, 2 to the x, which the graphic, it doesn't ever hit 0, it's got a horizontal asymptote as we go off toward the left, and as we go to the right it's going to infinity. And let's put our 3 to the x in green. Okay, now what happens is the base gets bigger, so we call the a value the base. So here we've gone for a base of 2, and here this one has a base of 3, and as we got bigger we saw that the graph got steeper. And if you think about what these functions mean, you know, you're either taking 2 to an exponent or 3 to an exponent. And if you're multiplying 3 by itself multiple times, that's going to grow faster than if you're just multiplying 2 by itself. Okay, now let's look at what happens when we use fractions, or numbers between 0 and 1 instead of the numbers we did here. So let's look at 1/2 to the x. Okay, so one thing you can notice is that compared to when we had 2 to the x, this has reflected across the y-axis. It's been a horizontal reflection. Now, why does that happen? Well, this is the same as 2 to the negative x, because that would be 1 over 2 to the x. And so remember, our reflections are when we've put in a negative x instead of an x. So if we compare that to 1/3 to the x, we'll make that bold just so we can tell the difference. Okay, we see it there. So we'll do the 1/2 to the x in blue and the 1/3 to the x in green. Okay, so just an introduction, and the big thing to know is here, where you're plugging in values is actually an exponent.